I'm now starting the homework questions on page 166. And for the questions on page 166, I will be starting with example number 1, where I need to find the derivative of the following functions. Most of the functions in this video will have to do with the function y equals to e to the x, and the derivative of e to the x is itself, which is e to the x. Okay, so for question number 1, I have y equals to e to the power of 3x squared. Now, when you're taking the derivative of these e functions, usually the first step is you just copy out the original problem, which is e to the 3x squared, and then you take the derivative of the exponent, and in this case exponent is 3x squared, so the derivative of 3x squared is going to be 6x. So that would be your final answer, and if you want to move the 6x to the front, you may. So the final answer could be 6x times e to the power of 3x squared, and that would be it. Moving on to question number 3, I need to take the derivative of y equals to tan of e to the power of root x. Alright, so in order to find the derivative, I would start by finding the derivative of tan, and the derivative of tan is secant squared of the inside, so secant squared, and the inside is e to the power of root x. So that's the derivative of tan, and then the chain rule states that I need to find the derivative of the inside function, which is e to the power of root x. So if you're finding the derivative of e to the power of root x, you can start off by copying out the function, which is e to the power of root x. And then to complete the derivative, I need to find the derivative of root x. Now, root x is the same thing as x to the power 1/2. So if I use the power rule, the 1/2 would come in front. So that would be 1/2 x to the power negative 1/2. Now, although this answer is correct, you can definitely simplify this. So I can move the, I can just write out secant squared of e to the power of root x. That remains the same. And then this part here in green, I can just tag that along. That's e to the power of root x. All divided by, now this part right here in blue, this x to the power negative 1/2, you can just park that on the bottom as a root x. And then finally this 1/2, this 2, you can just park that down there like that. So you need to have 2 root x on the denominator, and that would be your final answer there. Okay, let's move on to question number 5. Y equals to 4 to the power of 1 over x. And if I'm taking this derivative here, I can start off by writing out y prime. And a lot of these exponential functions, you can start off the derivative by writing out the original problem, so 4 to the power of 1 over x. And then you need to find the derivative of 1 over x. Now, 1 over x is the same thing as x to the power negative 1. If I find its derivative, the negative 1 would come out in front, so negative x to the power of negative 2. I need to subtract the power by 1. And then the rule states that you need to ln the base. So the base here is 4, so I need to write down ln 4 to complete the rule. Now, although this answer is correct, you should definitely try to simplify this. So this would be 4 to the power of 1 over x. And then the ln 4, this part right here, I can just tag that at the very end, all divided by, and then this x to the power negative 2, I can park that at the bottom as x to the power of 2. And then finally, this negative sign, I can park that to the front, and then that would complete the problem there. So that right there is your final answer in this box. Okay, let's move on to question number 7 here. So for question number 7, I have y equals to x to the power of root 3. Now for this particular problem, the root 3, this is just a number, right? So anytime you have a number, you can just apply the the power rule. I don't need to do anything fancy here. So the root 3 would come in front. The base x would remain the same, and then the power, you would just decrease the power by 1. So since the power is just a number, you can just apply the power rule. Okay, that's it for question number 7. Let's move on to the next one, question number 9. Now for question number 9, there's different ways of doing this problem, but the quickest way would be to recognize that e and ln, whenever e and ln are kind of next to each other, or if you have e to the power of ln, they're inverses, so they just cancel each other out. So now you're left with y equals to x here, so this x here is the only thing that survives. So yeah, you can simplify that down into y equals to just x, and then this derivative is pretty easy. The derivative of x is just 1. So that's probably the fastest way to do it. If you don't want to do it that way, I guess here's method number 2. Although method number 2 does take a little bit more work, you can also try the similar kind of strategies that we used in the first few problems. So e to the power of anything, you can start off by taking the derivative by writing the original problem, so e to the power of ln x. And then the rule states that you need to find the derivative of the power, and the derivative of ln x is 1 over x, so that would be 1 over x. And what you need to do here is you need to continue to simplify this. So e and ln, when they're next to each other, they just cancel each other out, and now you're left with just this single x here. So that single x can just move down as that, and then the 1 over x remains, and then you have y prime equals, and you'll notice that the x's just cancel off, and the only thing that survives is 1. So the final answer there is also 1 using method number 2. Okay, let's move on to question number 11. For question number 11, I have to use the product rule in order to find the derivative. So there is one part of the problem, and this blue part is the next part of the problem. So from those two colors, it should be obvious that you need to use the product rule here. Okay, so if I want to take the derivative of x squared, that's going to be 2x. So the derivative of the first term times the second term, plus the first term, which is just x squared, and then you need to find the derivative of 3x. Well, that's an exponential function, and those derivatives start off by writing out the original problem, so 3 to the power of x, and then you would now take the derivative of sorry, let me just erase this for a bit. You would now take the derivative of the power, and the derivative of x is just 1. So the derivative of that is just 1, and then you would finish off by taking the ln of the base. So the base here is 3, so you'd finish off by writing ln 3 to follow the rule. Okay, so if I just clean this up, this would be 2x times 3 to the power of x plus, now all of this would just be x squared times 3x times ln 3, so I guess I can just clump that all together here, like that. And after that, I guess you could do some factoring here. Here's an x to the power, 3 to the power of x. I can factor that out. So if I factor out the 3 to the power of x, I'll be left with 2x plus x squared times ln 3. And then you'll notice that I still can factor out an x here, and from those blue x's here, I can factor out one more x. So 3x on the outside, I'll put the single x out there, and now I'm left with just 2 plus x ln 3. So a few steps there to get to the final answer there, but that right there would be the most simplified answer for that particular problem. Okay, let's move on to the next one, question number 13. Now this one's going to be a bit of a long one just because it seems like I have to use the quotient rule here, number 13. Actually, this one's not too bad. I would definitely use the quotient rule here, and then I would have to simplify it towards the end. Alright, so for this particular problem, the quotient rule states that I need to take the derivative of the numerator first. Now, since that's an exponential function, step number 1 is we would just write out the original problem, e to the power of negative 2x. And then the rule states that you need to find the derivative of the power, and the derivative of negative 2x is just going to be negative 2. So that right there is the derivative of the numerator, and then we would times it by the denominator, which is x, and then the quotient rule states that I need a minus sign, and then I would write out the top, the numerator, which is e to the power of negative 2x times the derivative of the bottom. The derivative of the bottom is, well, the function is x, so the derivative of x is just 1. And then I would divide this whole thing by the denominator squared, so the denominator is x, so x to the power 2. Okay, and after that, I guess I could simplify a few things here. If I look very carefully here, there's an e to the negative 2x and an e to the negative 2x there, so I can factor that out. So that would give me e to the negative 2x, that's my common factor for now. And then I'm left with all this, which is just negative 2x, so the negative 2x can remain. And then what's left on the other side is this negative and this 1, so that would just be negative 1. Close that bracket, and then I would divide that by x to the power 2, and that's y prime equals. And although this is an okay answer, the other thing that you could factor out is this minus sign now. So inside the brackets, both terms have a minus sign. So if you want to factor that out, the minus sign would just go over here, and then the signs would just change to positive signs. So that right there would be your final answer if you went ahead and factor out the minus sign. So here's my minus sign right here in purple if you can't see it. So if it's not clear, then I'll put it right there, minus sign y prime equals to all that. Okay, so that concludes question number 13, and now let's move on to question number 15. So for question number 15, I have, remember pi is not a variable, pi is like a number, so that's a constant. So what that means is I need to have a ln of that in my answer eventually. So once again, this is another crazy exponential function, and the good thing about exponential functions is that when you take the derivative, you always start by writing out the original problem. And then you would follow that up by taking the derivative of the power here. So if I went ahead and found the derivative of that, I would have to use the product rule. So let me just use some different colors here. So it's a product rule because there's two functions, green times blue, x times cos x. So the derivative of the first term x is going to be 1. So 1 times the second term, which is cos x, plus the first term, which is x, times the derivative of the second term. Now the derivative of cos x is negative sine x. Let me just put that in a bracket there. So negative sine x, close the bracket, and then close that bracket. We're almost done, and remember, because this pi here, since that's a constant, the rule states that whenever you have a constant to a power, you need to ln the base, so it'd be ln of pi. And that right there is my final answer. I'm not going to really simplify it. The only way I can really simplify this is just taking this plus and this minus, that minus and that plus, timesing those together to give me a minus sign. So if I did that, it would look like something like that, and that's pretty much all I can really do for that particular problem. Okay, let's move on to question number 17. And for question number 17, I think this one's going to take a bit of work here to finish this one here. So if I want to find the derivative of this particular problem, I definitely need to start off by using the quotient rule for this problem. And the quotient rule states that I need to find the derivative of the numerator here. So that's going to be y prime equals 2. Okay, so if I want to find the derivative of the numerator, let's find the derivative of each term. So e to the power of x, the derivative of that is just e to the power of x. And then I need to find the derivative of this guy right here, e to the power negative x, which is e to the power negative x times negative 1. And then there's a minus sign here in red. And then I'll close that bracket. And then I would have to times that by the denominator. And the denominator here would be, put that in a bracket, e to the x plus e to the minus x. So that's the first part of the particular problem. Now I want to simplify this just a bit before I move on. You'll notice that there's a minus sign here and a minus sign there. So if I multiply those together, that should be a plus, right? So that should be a plus, and then I can just get rid of all that. And then I guess I can just erase this and just move it over a bit. So I just need to times this by the bottom, which is e to the x plus e to the negative x. All right, so that's the first part of the quotient rule. And then the quotient rule states that I need to minus. Now, what am I minusing? I'm minusing the numerator again. The numerator as the just like it is, e to the x minus e to the power negative x. And then the quotient rule states that I need to times by the derivative of the denominator. So the derivative of the denominator, if I do this very carefully here, the derivative of e to the x is e to the x. And the derivative of e to the power of negative x is e to the power negative x times negative 1. Now close that off, and then you would times this by the denominator all squared. So the denominator is e to the x plus e to the power negative x, bracket, bracket, all squared. Okay, just before I continue here, if I take a look at this bracket right here, there's a minus sign and a plus sign, right? So if I multiply those together, the thing that survives will be a minus. So those two yellow signs there, plus and minus, will just give me a minus, right? So I'll erase all that and put a minus sign here. And then I will close the bracket there. All right, so that's how you can kind of clean up your algebra as you're doing this problem. Now, one of the reasons why this problem is a little bit difficult is because now you need to, in order to simplify this, you need to FOIL this out. So if I do this very carefully here, e to the x times e to the x, that's going to be e to the power of 2x. And then after I finish with that, I would do the first guy times this term over here. And if I do that very carefully, that's going to be e to the power of x. And then this negative x right here, that just kind of tags along on the power. So when the bases are the same, you need to like add the powers. So x plus negative x, which is the same thing as x minus x. Okay. And then after that, let me just get rid of that color there. Now I take my second term here, and then I would multiply that with this term here. And if I do that, that's going to be plus e to the power of negative x plus x. And then after I'm done that, I would take this guy and I would take this guy here and multiply it with that guy there, and that's going to be plus e to the negative x minus x. So we're using a lot of exponent rules here. So the general rule is if you're multiplying with the same basis, you need to combine the powers. Okay, and then there's a minus sign here, so let's put the minus sign over here. Okay, so now I need to FOIL the other side now. So if I have this guy right here, e to the x times e to the x, that's going to be e to the 2x. And let me just kind of put another bracket right here, just because I don't want to have this minus sign affecting my results just yet. So let me just continue to FOIL here. So e to the x times this second term right there, that's going to be minus e to the x minus x. And then if I keep on FOILing here, now I need to take my inside guy, and then I need to multiply that out. So that's going to be minus e to the negative x plus x. And finally, the last one is this guy times that guy. That will give me a plus sign, because there's two negative signs, e to the negative x minus x. And then I would just finish that off by closing the bracket. So this is looking quite heavy right here on the algebra here. And then just remember, I'm just dividing all of this by the denominator all squared, which is e to the x plus e to the negative x all squared. Okay, now before I continue on here, I really want to take the time here to simplify this just before I move on. So let me just kind of blow this up a little bit more. Okay, that looks good. So over here, x minus x, this part here in yellow, x minus x is going to be 0, so I can just erase that to make that be 0. And e to the power 0, or anything to the power 0, is always going to be 1. So I'm going to erase that and just replace that with a 1. Same thing over here, negative x plus x. If I collect like terms, that's going to be 0. And e to the power 0 or e to the power anything is always going to be a 1, so that becomes a 1. And then this part right here, negative x minus x, that's going to be e to the power of negative 2x, like that. And then over here again, if I look at these powers right here, if I combine the like terms there, x minus x, that's going to be e to the power of 0. And this part right here is also going to be e to the power of 0. And anything to the power of 0 is always going to be 1. So if I can erase that and replace that with a 1, and replace this, and that will also be a 1. And this part right here, negative x minus x, that's going to be negative 2x. So I'll erase that and write down negative 2x. And you'll notice that the algebra is slowly starting to come together here. And now you'll see that if I take this purple minus sign, and if I actually distribute that, actually before I distribute that, negative 1 minus minus 1 minus 1, that's going to be negative 2. So let me just replace that with the negative 2. And you'll notice that this minus sign, if I distribute that in, that's going to become positive 2, right? So that's going to become positive 2. And then if this minus sign distributes with that guy, that becomes a negative sign. And then that should take care of all the signs. And then you'll notice that this blue guy, the e to the 2x, and this part right here, if I combine those guys, they just cancel out, right? So those are like terms, I can just cancel those out. And then you'll also notice that this guy right here and this guy right here, those are also like terms, they cancel each other out as well, so I can cancel those guys out. And then you'll notice that I have a plus 1, a plus 1, and a plus 2. 1 plus 1 plus 2, that just gives me 4. So I'm going to erase all that. and then I just have a 4 here. So a little bit of algebra there, and once you do all the algebra there, you do get y prime equals to 4 over e to the x plus e to the power negative x, all in brackets to the power 2. So that would be your most simplified answer after you do all the FOIL, you collect your like terms, and then you simplify. Okay, let's move on to the next few problems. Okay, let's move on to question number 18 here. And for question number 18, this question will take a few steps to solve because it's an implicit derivatives problem. All right, so in order to do the implicit derivative problem, you have to take the derivative of the left-hand side, and you also have to take the derivative of the right-hand side. Now, if I take a look at the left-hand side, e to the power of x plus y, if I take that derivative, it would be e to the power of x plus y. And then the rule states that you need to take the derivative of the power. So the derivative of x plus y will be 1 plus y prime, close the bracket, and that's the derivative of the left-hand side. And then on the right-hand side, you'll notice that we have to apply the product rule here because we have two functions being multiplied with each other. So the derivative of 3x squared is going to be 6x times y. So 6x, whoops. Sorry about that. So 6x times the y plus the first part of the function, which is 3x squared, times the derivative of the second term, which is just y. So the derivative of y is just y prime. After that, I would go back to the left-hand side, and the e to the power of x plus y, you would just distribute that onto the brackets there. And once you do that, that's going to be e to the power of x plus y plus e to the power of x plus y, and then the y prime is just tagging along, and that equals to everything on the right hand side, which is 6xy plus 3x squared y prime. Okay, so the next thing I'm going to do is I'm going to highlight this term here in yellow, and I'm going to highlight this term here in yellow as well, because I want to move those two pieces. So I want to move this guy to that side and this guy to that side. And the reason why I want to do that is because I want the y primes all on the same side. All right, so this is just basic algebra. If you move the terms across, you just got to flip the signs. So I still want to keep this guy on this side. So e to the power of x plus y times y prime. And then if I move this term over, that's going to be minus 3 x squared y prime equals to 6xy. That one's done. And then if I move this guy over to that side, that's going to be a minus e to the power of x plus y. All right, so there you go. I'm almost there now. Now I need to factor out the y prime. So here's a y prime here and a y prime there. I'm going to factor that out because that's a common term. So y prime bracket e to the x plus y minus 3x squared, close the bracket, and that would equal to the right hand side, which is 6xy minus e to the power of x plus y. And then we're almost done. I just need to divide both sides by e to the x plus y minus 3x squared. Divide that by e to the x plus y minus 3x squared. And then these guys just cancel off, so if I erase that, I'm left with y prime now, so y prime equals to that. All right, so that's my final answer right there. Implicit derivative problem's not too bad, but you do need to move some terms around so you can factor out the y prime, and then the algebra there isn't too bad. Okay, let's move on to the last question for this video, question number 19, another implicit derivatives question here. So this one will take a little bit of work again. So I need to take the derivative of the left-hand side and the derivative of the right-hand side. Now I have e to the power of something, so in order to find the derivative of that, I can start off by writing out the original problem, e to the power of xy cubed. And then the derivative rule states that I need to take the derivative of the power. So that is a product rule, so bracket. So the derivative of x is just 1, so 1 times y cubed, plus the first term, which is x, times the derivative of the second term. The derivative of y cubed is 3y squared times y prime. and then I would close that bracket, and that would equal to the derivative of the right-hand side. The derivative of x is 1 minus the derivative of y is just y prime. Okay, so that's my first step in terms of taking the derivative. After that, let me just erase the colors here. I'm going to highlight this part here in yellow. So just like the previous problem, now you want to distribute that into the brackets. And when you're distributing that into the brackets, you're just kind of, putting all these variables together in a way. So plus, and then this would be actually this part right here. I'm going to rewrite that as 3x, and then the y squared and the y prime is going to rearrange the terms, and then I'm just going to attach the e to the xy cube at the very end there, and then that would be equal to 1 minus y prime. Alright, now this is looking very similar to the same strategy from the previous question. I'm going to highlight this term right here, and I'm also going to highlight that term here on the right hand side. Those are the two pieces where I'm going to interchange those two pieces, right? So if I interchange those two pieces, then I can factor out the y prime. Alright, so let me just finish off by writing the rest of the steps out. So 3xy squared times y prime, e to the xy cubed, and if I bring this piece over, that's going to be a plus y prime equals to 1. And then if I bring this piece that I'm circling in green to the other side, that's going to be minus e xy cubed y cubed. Looks really messy there. I'm going to erase all that. And then that's looking pretty good. And you'll notice that there's a y prime here and a y prime there. Maybe just erase this next line here just so that I have enough space here. Okay, I can factor out the y primes now. So y prime bracket 3x y squared e to the xy cubed plus 1 actually, and then close that bracket off, equals to 1 minus e xy cubed y cubed. And after that, I can now finally divide both sides by 3xy squared e to the xy cubed plus 1, and divide that side by 3xy squared e to the xy cubed plus 1. These guys cancel off, so I'm going to erase all that now. And then the y prime can move over. And then this right here would be your final answer after all that work. Alright, so that concludes this video, and I'll start working on the next one.